Good morning, everyone. You're listening to the Sci-Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie Bhanu
and Daniel Puentes.
Today we're here with Pratap Bhanu Solanki. Pratap, can you please tell us a little bit about yourself and your research?
I'm from Department of Electrical and Computer Engineering. I study underwater robotics in Smart Microsystems Lab. In our lab, we mostly focus on underwater robots, and there are variety of projects we focus on, like big robotic fish, optical communication systems, surface gliders, etc.
All of those projects sound really interesting, but which one are you focusing on for your thesis project?
I'm focusing on the underwater optical communication part. So give you a brief context why underwater optical communication. So you must have seen like iPhones talking about they can go deep underwater like 4 meters, but they can just go underwater for 4 meters. They won't really be working the way they work on surface, as the radio frequency signals like Wi-Fi, cellular signals and Bluetooth, they don't work underwater. The current industry standard is acoustic communications. But the problem with acoustic communication is there is a lot of delay and the bandwidth is pretty low. By low, I mean you can only send like text kind of messages with acoustic communication. And if you have to think about sending videos or live video communications, then you have to think of something bigger, like more higher bandwidth in terms of at least megahertz or gigahertz. And that's where optical communication comes into the picture.
When you mention acoustic signaling, I think of like a sonar. But whenever you say optical communication, I can't help but think of like light. So what kind of optics do you use for optical communication?
So as Chelsea asked, the optical means light. So yes, we use blue light for optical communication.
What is the advantage to using blue light in the water in the first place?
So the blue light, and to be exact, the wavelength of 470 nanometer is the wavelength which travels farthest in water. So that's why we use blue light.
And what messages are you transmitting with the light?
Currently in my research, I start with sending text messages about 1-2 sentences. And for a very particular setup, I have demonstrated sending a JPEG image captured by a camera from one robot to another robot.
How are you producing the blue light in the water as well?
On each robot, we have a small blue LED. An LED is like typical LED which we find in like our LED lamps at home. So it's the similar LED, but it's just, it produces a wavelength of 470 nanometers.
When I think about light penetrating through the water, I often think about what happens when the light scatters off water molecules and that creates a spread in your light. How does that affect how well your robots are able to actually capture that light and translate that into a message?
So scattering can be detrimental, but it can be advantageous as well. So in a normal situations, there are two robots in a pure water scenario. Then the light received by the other robot would have a better signal in strength in compared to the situation when there are like multiple suspended particles like in a murky sea water. So in that case, the other robot would receive a lower signal. It would be detrimental. But in other case, when there are two robots and there is an object between them, and where the one robot cannot see the other robot, but because of the scattering, some intensity of light is reaching other robots. In that case, scattering is helping us.
Well, that's interesting. So it sounds like then that these LED lights could be used to determine whether or not there's an object even in between the two robots in the first place. It could be used as an identification tool in some ways.
Yes. So that's like a solution to other problem actually. In early days when we don't have video cameras installed for the door, so they used to have a laser, and on the other side there used to be a receiver, and if a person is coming in between, they open the door. So that's like a good use case of this technology.
What is the purpose of your underwater robots?
About 2/3 of the Earth's surface is covered with water, but still we haven't explored much yet. And these underwater robots can be used for exploration, for climate change, for oil and gas spills, and say shipwreck, and say assisting divers. So there are like multiple applications for underwater robots. And so when these robots, they work together and they want to go underwater together as a team. They need a network system. But if there is no communication between them, then how would you create a network? That problem we are trying to address using this optical communication.
What are some of the challenges that are involved with optical communication systems in the water, anyways?
So that brings to the problem of my PhD dissertation. So this optical communication systems, it's a well-researched problem. I particularly do is solve the problem of line of sight. By line of sight, I means when two robots wants to communicate, they both should be looking at each other. If somehow they are not looking at each other, or if there is an obstacle between them, then this optical communication is not possible.
If two robots are randomly placed in a body of water in any random orientation, how do you know when the two robots are looking at each other in the first place correctly?
Each robot is equipped with a photodiode and an LED. So LED, what LED does is it transmits the signal, and photodiode receives the signal. So when photodiode receives the signal, it has a signal strength and it has a message. Based on the signal strength, it can figure out whether some message is coming or not, or whether there is a other robot sending message or not. For example, if there are two robots underwater placed in a random orientation, first what will they will do is they will randomly search for some light intensity. And when say one robot find a very little light intensity, it can figure out that there is some other robot transmitting something, but the signal strength is so weak that it cannot decode it. What it will do is it will rotate itself, so it will tweak around and then find if the intensity is increasing or not, and then using different algorithms which I used in my work, it tries to move in an orientation where the maximum light intensity is coming from. And if both robots are doing the same thing, they achieve line of sight. And when they achieve line of sight, they can do the best communication.
So Danny's question got me thinking about if you randomly drop the two robots in the ocean or in a body of water, what happens to them? How far apart can you separate the robots from each other before they can't communicate with each other?
So this how far they can communicate totally depends on how much power you want to invest in each robot. So for example, the robots we have developed in our lab for the 50-meter pool, we have tested that they were able to communicate. So that totally depends on how much power you want to invest, because if you put more power into your system, it will generate a brighter LED, and the signal from the brighter LED will reach farther in the water.
We talked about how the distance between the two robots can play a factor in how well the signal can be received by one of them. What other factors play a role in the efficiency of these robots?
If say you are in a lake and with these two robots, then of course the sunlight would be a major source of light which we don't want these robots to have, because the light from sunlight would be of course be much higher than the signal from the other robots. That will deteriorate the communication. So what our application is focused on is like deeper sea exploration, where you are say sufficiently below the surface, where the sunlight has very little strength. So where these robots, when they transmit, their signal is not deteriorated by sunlight.
Okay, so you're doing deep sea exploration. I once tried snorkeling, and I remember that whenever I was diving deeper that my head was hurting because of the pressure. How does your communication system within the robots that are underwater accommodate for the pressure?
When you are underwater and as you go deeper, the pressure definitely increase. So it doesn't affect much of the communication of the robot, but what it affects is your robot should be designed so that they can sustain that pressure. We were doing experiments with our robotic fish, which is called Grace. It's like 3 feet long robot, and it weighs about like 50 to 60 pounds. Went below certain depth, because of the high pressure, it compressed the fish such that its buoyancy decreased and it sank. The lesson we learned from that experiment is that we have to design our robot so that they can handle such large pressure. These submarines, they are actually designed that way. They can handle the pressure of such high pressure. When you go to like hundreds of feet of depth, the submarines can handle that, and these robots have to be designed that way.
What goes into building an underwater fish robot anyways?
Creating a robot, it requires majorly three engineering skills. Like you first deal with the mechanical aspects of the robot. So for example, a underwater robot like fish, you have to design it such a way that it doesn't sink, it does not always stay on the surface. You have to mechanically design such it in such a way that the water doesn't leak inside, and then you have like a propellers to move it around, and all other aspects of like how say a submarine moves. So similar miniature versions apply on an underwater robot. After that, it involves design of electronic circuitry to power each component and control each component using electronic circuit. And then on top of that, it requires computer programming where you program the robot so that it can work autonomously.
That's really cool. It seems like it's pretty complex to build an underwater fish robot. What motivated you to be in this lab or to work on this project?
So that goes back with my undergrad years when I was in India. I actually learned swimming in undergrad when I used to use the college swimming pool to learn the strokes and all. And I find that I really enjoyed being in water. And if you go deep, it's kind of a different kind of a meditative environment. It's therapeutic. And then I met a professor there who asked me if I can work on development of a robotic fish. So I said, wow, that's really beautiful. Like I can have my interest of robotics and being underwater at the same time. So then I started building the robotic fish, and it didn't come out as fancy as I was expecting because it was my first hands-on experience on an underwater robot. So then I thought, okay, maybe I need more time for work on underwater robotics. Then I started searching for labs working on robotics and especially underwater robotics in United States, and I found my professor Shabutan. He has done a lot of work in underwater robotics, so I applied to him, and then I came here at Michigan State for PhD.
What ways can students get involved with amateur robotics on MSU's campus?
There are multiple opportunities to be engaged in robotics community on the campus. So there is a student-run unmanned systems club where mostly they work on quadcopters, drones, etc. They build them from scratch, so the students can learn a lot about creating of robots from scratch stuff. And then there are professors. There are many professors working on robotics, which they always look for students who can help the grad students in their research, that they can have a good experience of robotics research and they can figure out if they want to continue it in their grad school.
And Pratap, are you involved in anything else here at MSU?
So outside my lab, these days I actually train with the MSU Triathlon Club. I joined the club last year, and I find the sport of triathlon really interesting and inspiring because it involves three sports: swimming, running, and biking. And you can be bad or good at all these three sports at the same time. So it's fun to attend the competitions, participate in the races with the team, going out to nationals like the collegiate nationals. So that was fun. Apart from that, I signed up for MSU Scuba Club. Will be going for a trip to Mexico next spring break. So I'm really looking forward to that.
I hope you enjoy that trip to Mexico. Maybe you can test some of the robots that you've been working with in your laboratory and test them out in the real field.
Yeah, but my robots are currently not designed for the ocean, so I'll keep them to the pool.
Even so, thank you so much for coming in today to talk to us about this incredible research.
Thank you, Daniel and Chelsea. I really enjoyed talking to you.
For those that have tuned in a little late, you've been listening to the Sci-Files on Exposure. Thank you for Jeremy Whiting, our general manager, Olivia Mitchell, our station manager, and our program directors, Amba Konetsky and George McNeil. Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to scifiles@impact89fm.org. We'll see you all next week on Sci-Files.